Pydantic just dropped its latest project, Pydantic Graphs. I know what you're thinking. What is it? And how does it compare to LangGraph? Well, that's exactly what we're going to be diving in today. In this video, we'll break down what Pydantic Graph really is, see how it stacks up against LangGraph, and most importantly, explore the world of graph-based workflow orchestration. Let's start with a little bit of demo. What are we going to learn how to build today? Okay, it's a demo which people who have been following these streams for a long time, they already know that. I've made this like 1 billion times already. We're going to make a task management app. We're making a task management app, right? So essentially we can ask this agent to give me all my tasks. What it's going to do, it's gonna figure out that, okay, I'm asking for, my intent is to get tasks. Then it actually went ahead, called my database, and got all the tasks. Again, if you know what I do, you know that this is a real database. It's not just a file, it's an actual database running in the background. And then we go ahead and summarize the task. Okay, cool. So we can get the tasks. That's not the fun part, that's the easy part. Let's make it a little bit interesting. So what I'm gonna do now is I'm just gonna say that, hey, I got my groceries. I'm not gonna give it a command. I'm just giving it a statement that, hey, I got my groceries. Now, the agent was smart enough to figure out that we actually are trying to mark a task as done. It then went ahead and figured out that the real task in the database, it's called buy groceries. And it is present. It is present in the database. And then it goes ahead and updates the task. This is what we're gonna be building. We built this using just Pydantic AI with no graphs, and we had some opinions there. We'll revisit that code in just a bit. But this is what we're going to try and build again in Pydantic Graphs. This is how Pydantic works. Just a quick recap, right? Whenever you're working with Pydantic, essentially what you're doing, you make an agent object. That's the core of everything. Pydantic AI revolves around the agent object. And in this agent, you pass in a model. So I'm passing in the OpenAI model. Just because we are using OpenAI doesn't mean we are actually using the OpenAI model. I'm technically using Llama 3.1 8 billion parameter whenever you see the word model small, and model medium is essentially Qwen 2.5 32B. Okay, just set your environment variables in this file, rename this to .env, and you should be good to go. So again, you can use OpenAI, but I'll judge you. I'll judge you if you do that. Don't do that. Actually, you can do that. It's fine. Cool. So you just make an agent object, you pass it a model, and you pass it a system prompt or whatever. And essentially you just do an agent run, right? And you give it the query. That's pretty much it, right? This is your system message, and this is your user prompt, technically speaking. Sounds good. But of course, Pydantic gives us a lot more features. For example, I can dynamically generate a system prompt as well. What I'm doing is I'm essentially saying that this is my default system prompt. Now I want to append something to this. So I want to inject my name or the user's name in the system prompt so that the agent always answers using the user's name. Now this is interesting because we don't want to hard code the name in the system prompt. It needs to be dynamic. And one of the features which I really love about Pydantic, this is like literally my favorite feature, is dependency injection. So in Pydantic, I can always go with, I can just say that, hey, I have a dependency class. And then while giving it my prompt, I can pass a dynamic dependencies object, which I can use while generating the system prompt. It's pretty cool. It's pretty cool stuff. In fact, I'm pretty sure that I'm going to have another stream where I'll be having a guest, and we'll be talking about why this is such a powerful feature, especially when it comes to privacy. How can you make sure that you have RBAC in agents, RBAC in agents. So it's really cool stuff. Another cool feature is structured responses. And maybe a third one could be tool calling. It does a little bit fancy stuff for tool calling as well. It's pretty good. I like it. But this is essentially what Pydantic AI does. Now you'll see some problems immediately. The first problem you'll see is that whenever I do run, like whenever I actually take this agent and say that, okay, run this prompt, there is no way to control how the agent talks to the model. There is no sense of control around how the agent actually talks to the model, which means, in simpler words, there's no notion of a workflow. In our example, which we saw in the demo, which we saw, we have a workflow, right? We start with step A, which is classification. Then we had a second step is identifying the title. And the third step was actually calling the tool and updating it in the database. This is a workflow. Pydantic AI has no notion of a workflow. All it does is call an LLM. That's pretty much it. I mean, if you're not using features like dependency injection and stuff like that, might as well just use the OpenAI SDK. Like, why not? Why not? Because it's not doing anything fancy, okay? There is no way to make it say that, okay, you need to do this first and then you need to do that. And then it doesn't work that way. It's just going to make a prompt and it's going to give you the answer. That's pretty much it. So if you wanted to build the app which we saw in the demo, how would you do that with Pydantic AI? We did see it in the last stream, but let's go through it again. Yeah, this is how you do it. Essentially, you make different agents. So you'll have one agent for every task you want to do. So going back to the demo, I have one agent to classify stuff. I have one agent to figure out the title. I have one agent to actually call the tool. So I have 3 agents going on here, right? And you can actually see that in the code. That first, I have my intent classifier agent and I'm just saying, hey, run this query. I get the result. But now the intent could be to add a task, to get a task, or to mark it as done. So what do? I just do a switch case. This is where I'm leveraging the structured response feature of Pydantic AI. This gives me a structured response. So you see data.action, it's not a string response, it's a structured response. And in my structured response, I could be like, okay, I'm either going to get add task, I'm going to get tasks, or I'm going to mark tasks as done. These are the different actions I can get by my agent. And based on that action, in each case, I can just go ahead and call another agent. In get tasks, I'm calling 2 agents because first I need to get the task from my database and then I need to summarize it. Similarly, if it was mark task is done, I can just call the title matcher agent so it can figure out the title and stuff like that. And if the title was present, I can again mark it as done in the database. What I'm essentially trying to say is Pydantic AI lets you write your workflows in vanilla Python. And that's not going to change, at least from their documentation. Their documentation clearly points this out. Pydantic AI will leverage Python's familiar flow control and agent composition to build your AI-driven projects. Just a way of saying that, hey, you're just going to use simple vanilla Python to do all of this. No graphs, no state machines, no workflow orchestration, just use switch case, just use for loops. And that's good. That's actually not bad. The problem arises once the flow gets a little bit more complex. And the more complications you keep adding like this, you start introducing cycles like for loops, going back to a previous node, or maybe add a bunch of switch cases and things like that. The moment your workflow starts getting complex, this is a nightmare. The code is ugly. It's not maintainable anymore. It's just so hard to maintain code in this form. That's one of the biggest problems of Pydantic AI. Again, I'm not saying you cannot do it. You can do everything you want. I mean, you can technically do everything you want without using Pydantic AI. You don't need an agent framework. You can just use an OpenAI SDK. I mean, you don't even need to use the OpenAI SDK. You can just call REST APIs directly. Technically, you don't need to use anything, but it's just inconvenient. It's very annoying, and the code is just so difficult to follow after it reaches a certain point. Another problem, which is not really related to graphs, but it's a problem, and I'm going to complain about it. And you know what? It's my stream. I can complain about whatever I want. So I'm going to complain about this. See what I'm doing here. I am technically crafting a query to talk to that agent outside the agent. I'm not sure if you follow this along. This is a very important point. So whenever you use agents or LLMs, you already know that they're very sensitive to how you give them instructions. So if you change the instruction format, the behavior of the agent can change. This is the instruction. This is how you give instructions to the agent. But the problem is the guy who wrote, or the girl, I don't judge. Everybody can do this. Oh my God, that's such a bad way to put it. Oh my God, I'm the worst. This is so bad. Please don't cancel me. Whoever wrote this agent, he knows or she knows the best way to give it instructions. The consumer of the agent, the girl making the workflows. I'm so conscious right now. The guy consuming the agents might not know the best way to give it instructions, which means that if I wrote the text summarizer agent, and you're using it. And what if you don't give it the instruction in this format? Instead, you just give it the data directly. Maybe the agent won't work. Maybe it will give you bad answers. Maybe it just stops working. You never know. This is what I call a leaky abstraction. the author of the agent has not contained a very integral part of the agent, which is the instruction, or rather the prompt. The consumer of the agent will have to make sure that they put it in the right way. I think it's a quick fix. You know what? I should actually raise an issue for this. Like how they have an at system prompt, they should have like a at user prompt and maybe just let the agent craft the user message directly. But as of today, they don't have it. I'm definitely going to raise an issue for this. I keep forgetting. I don't like this feature. Is it relevant to graphs? Absolutely not. But I just want to point it out anyways. The first problem was workflows can get ugly. The second problem, which I think is instructions are kind of exposed to the consumers. And the last problem is, I think this is the biggest one. The last problem is that it's all written in Python. I don't like Python. I really don't. Cool. All right. Oh my God, we've been talking about the problems with Pydantic AI for far too long. Far too long. So we know the problems now. So what comes next? So let's look at graphs. Actually, you know what? Let's draw some stuff first. What's the concept behind Pydantic graphs? Okay, or LangGraph for that matter. They are essentially orchestration tools. Essentially, it's just a bunch of nodes. So what do I mean by that? So think of how we studied computer science back in school, man. They used to make us make these crappy workflows. I know workflows are supposed to be from top to bottom, but I'm weird. I kind of do it this way. We call them flow charts. Yes, that's the word I was looking for. It's a flow chart. Thank you so much. I'm not a computer science student, okay? So I'm allowed to mess things up. You know what? I give up. But yeah, the point is you have graphs. So you could have like a graph saying that, okay, do something and then do these two things. And once both of these things are done, then end it, right? You could do something like that. Or you could also say that, okay, don't do both of these, do one of these. Based on the output of this node, we want to change what happens next. So it's either going to be node 2 or it's going to be node 3, right? It's just a flow chart, guys. It's just a flow chart. What is a node? A node is nothing but a function, a stupid Python function, a stupid Python function. Do whatever you want in a function. I mean, it doesn't even have to be an LLM call, technically speaking, okay? It's just a function. Now, there are two important points in any workflow system. First is flow control. How do you decide what comes next? How do you decide whether node 2 is going to come after node 1 or is node 3 going to come after node 1? How do you decide that? One way to do it is let node 1 decide that. So let node 1 return node 2. And if it returns node 2, then node 2 gets executed. If it returns node 3, then node 3 gets executed. The node is responsible to say who comes next. Another way to do it is don't return nodes. Instead, just define these nodes. Right? So you define node 1, you define node 2, so on and so forth. And somewhere else, you essentially create relationships. So you say after node 1, I want node 2. And after node 2, I want node 3. What? Something like that. LangGraph is this. LangGraph does this. LangGraph explicitly defines the nodes and edges. I'm going to give you a quick look so that you know what I'm talking about. So this is just LangGraph code. Again, we don't have to get into it, but it's just a function, right? A node, just a function, nothing fancy. I'm calling an LLM inside here. And then within the graph object or in the graph builder object, I register the node. So I'm saying that my graph has only one node. And then I'm adding edges. So I'm saying that, okay, first comes start and start goes into first node. Then comes first node and that goes into end. So nodes have nothing to do with edges. Pydantic graphs doesn't do this. Instead, Pydantic graph goes in the total opposite approach. This is a node in Pydantic graph. Again, think of it just as a function. Don't worry about what all of these things are. We will get to it in just a bit. But it's just a function, okay? At the end of the day, it's just a function. And yes, I'm using LangChain within Pydantic graph. That's right. I'm going to hell. I'm going to agentic hell. The important point is it's just a function, but look what's happening here. The function is returning what comes next. So the function is essentially saying that, okay, the next node in the graph is the end node. So those are two major approaches. One is where we just define the nodes and then we explicitly bind each nodes together in the form of edges. That's what LangGraph does. Pydantic, on the other hand, doesn't do any of that. It just goes ahead and says that, okay, every node is responsible to return the next node in the sequence. But that's one thing you really need to understand, okay? These are graphs. These are essentially something called state machines. Actually, let's build it from scratch. And let's just try to draw what we saw earlier as a graph so we get some idea, okay? Let's do it. So what happens in this graph? So we first have an intent. Okay, this is not a graph. I mean, obviously this is a workflow written in pure Python. But if I wanted to do it in graphs, how would it look like then? So we first have an intent classifier. Sweet. So the first step was the intent classifier. So I'm just going to plug that in. Okay? Step 1, intent classifier. Bam, we got you. Now, what can the intent classifier give us? If the task was add task, we go to the task executor agent. So I'm just going to call it task exec. Cool. This will only happen if it was add tasks. So it's not a solid line, it's a dotted line. It's a conditional. And then once the task has been executed, what happens next? Okay, this case, we don't care about it. We don't care about this case. We directly end it. So technically we end it. We end it right after this. And this is going to be a solid line. First step done. Add tasks. Now, what was the second thing? The second thing was get tasks. So if the action was get task, then we first call the task executor again, but we then call the task summarizer. So technically, we call the task executor for get and add, but we are going to call the task summarizer conditionally. Actually, you know what? This doesn't look that good. We need to make our flowcharts look good, guys. It's important. It matters to me. It really, really matters to me. I think this is better, much better. Okay, now what I can do is this will be followed whenever we are doing add tasks, and task summary would kick in if we were doing get tasks. Whenever I use dotted lines, just remember that that's a conditional. It's not always going to be that. It's a conditional. It could be this or that. What's next? So we did this, and obviously after this, there's nothing that happens. It just ends. And then the last one was if the action is mark a task. So we go, where do we go? We go to the title matcher. So we go to the title matcher if the action was mark task as done. So title matcher. And we come here and it'll be a dotted line again. Let's copy this and we call it mark task as done. Sweet. Cool. What comes after this is, if the title matcher says the title is not present, we raise an exception. So technically we end it. So we technically say we are going to go here. If the title was present, we're going to call the task executor agent again. So this would essentially be here. So after the task executor agent, if it was add task or mark task is done, we go to end. Otherwise, we go to task summary. So this is the graph equivalent or the flowchart equivalent of our demo. This is essentially what was happening in our demo. So this is essentially how you architect stuff as graphs. Okay, so now let's get into how does it work in code. The graph you're making is going to be really simple right now. We're just going to have a start node, then one node, and then we'll end it. So it's just a single node graph. Let's just start with that and then we'll build from there. Okay, so what is a node? Because Pydantic Graphs is really Pydantic focused, everything is very class heavy. It's not functional. It's very object oriented. Right? I think that's just the way Pydantic works. It's very object-oriented. The very fact that they do dependency injections and stuff like that, very object-oriented. So nodes, remember I said every node is just a function? Well, I was lying. Every node in Pydantic is a class. But it's essentially a class which has this main executor function or the run function. So you could think of it like a function. It's just like a class and then a function. It's a little verbose, I'm not going to lie. Just LangGraph is less verbose than Pydantic for sure. Let's just go through it. So what do? You essentially create a class. This class is going to extend the base node, which you get from Pydantic. So it's just a type of base node, right? So it's a Pydantic Graph node. Don't worry about these things for now. These are some things. We'll get to it in a minute. Then we have a run function. And because it's a run function and it's a method and not just a function, it's a method within this class, you have access to the class member variables. So technically, I could have gone ahead and created as many member variables as I want. I could even create as many member functions as I want or methods as I want, and I could just use them here. So a very OOPS or object-oriented style of building nodes. If we quickly jump to our good friend LangGraph, LangGraph is just a function. That's pretty much all it is. It's just a frigging function. Some interesting things to note. In LangGraph, we were returning the state object. People who are not aware of what LangGraph is already, ignore whatever I talk about LangGraph. Just focus on Pydantic Graphs. But because I said the objective of this stream is going to be to put it in perspective against LangGraph, I'm going to talk about it, okay? So LangGraph, the people who already know it, is essentially, it's a very explicit state machine in the sense that each node takes a state and augments the state. That's what every node does, right? And then you map the edges on how different nodes are connected separately in the graph builder, right? So the node has no idea who's going to come in next, because all the node is saying is that give me the state and I'll return the state. So if there are two nodes which want to talk to each other, they have to do it through the state object. Pydantic Graph has a very different approach. It's literally returning what comes next. Let's take a pause here. We essentially create a class. We implement the run function, do whatever you want in the run function. Like I said, you can literally go evil and start using LangChain. Do you, man. You do you. I don't care. Or you could use Pydantic agents within it, or you could just write if-elses and be a true AI genius. You could do whatever you want in this run function. It doesn't even need to be AI, okay? And you simply return end, because you want to end the graph here. You're making a single node graph. How do you run the graph? You make the graph object. Again, this is something Pydantic gives us. So you make a graph object. You explicitly define the nodes in that graph. You don't need to define the edges. Why not? The node is going to return which edge comes next. And what do? You simply run the graph. And while running the graph, you explicitly define that my starting node is the first node. But remember, our first node is just a data class. So I can initialize the first node and pass it all its dependencies. Actually, I shouldn't use the word dependencies. I can construct the first node object directly. It's a constructor pattern, guys. Pass in the member variables up front. That's essentially what Pydantic Graph is. So basically, LangGraph, no GT Tech Lab, it's not the same as LangGraph. In LangGraph, the node doesn't return which node comes in next. You explicitly define edges in the graph builder. Each node is agnostic of the other nodes. So the node doesn't know if there are other nodes in the system or not, or how many nodes there are in the system. It just does its job and it's done. In Pydantic, your node is aware of what comes next. GT Tech Lab says that's not true. LangGraph added the command class. Yes, you're right. You are right. Okay, my bad. I kind of missed it. You are absolutely right. LangGraph has added support for the command class, which again, I really don't like it, but I mean, sure, people like it. So even in LangGraph, now you have the ability to return, instead of returning the state, you can return a command. And in the command, you can say which node do you want to go to and how do you want to update the state. So yes, LangGraph gives you flexibility to do both. Thanks for correcting me, GD Tech Lab. Extra points to Gryffindor. Are you Gryffindor? I don't know. What do you prefer? Whichever team you're in. Extra points to that. I'm saying this again. Pydantic Graph is really new. Maybe they make it flexible as well. These APIs can change. So far, it's different. Prashant, just for you. Let's say I have two nodes. In that case, so I have node 1 and node 2. So this is my first node and this is my second node. So if I wanted my first node to go to the second node and not end, it can simply return the second node. But again, remember, second node is a data class. So I can use the constructor pattern to fill up its member variables. I think that's what they call it. So you're not just telling what comes next, you're literally passing it data. So there are two important points which you need to remember when it comes to evaluating any workflow orchestration tool. Now, this is my opinion. An opinion. Take it with a grain of salt. Okay? But there are two important things that you need to remember when you're evaluating any workflow orchestration tool. The first is the concept of data. As you're going from one node to another node, how is data moving between them? How is the data flow going to work? That's point one. The second is, what control flow mechanisms do you get? How easy it is for you to control what node comes next, okay? Those are the two most important things. I mean, there are definitely more, especially around long-running workflows and things like that. We can get into that another day when we do a stream just on workflow orchestration. Those are the only two things, not the only two things, but those are the most important things which matter when you're talking about container orchestration. So let's start with data. How do you pass data between nodes in Pydantic Graph? So I have two nodes here. I have node number 1, I have node number 2. And essentially, because these are just classes, I'm starting the graph by saying first node, you take my user ID straight up. So first node can just access the user ID using self, like what it's doing right here. Just use the user ID the way you did, get a response back, and then the first node is calling the second node. And how is it passing data to the second node? The way it's passing data to the second node is by simply calling the second node and passing the values that it needs to pass to the second node in a constructor. Very important point, guys. We are using the inherent Pythonic way of passing data around objects. Simply while creating an object, like use the constructor pattern to pass in data, right? So when I do this, the value contained in result.contain will be stored here. Obviously, that's how Python works. It's just Python, right? There's nothing fancy going on here. And then the second node can simply use it by referencing itself. We are passing data between nodes just how you would do it between objects in Python. Just make an object, you're using the constructor pattern to pass data around. This is a really good way to pass data around. I mean, it's kind of good, it's kind of bad. Again, opinion territory, guys, opinion territory. It's really good in the sense that you're passing data to the second node, but no other node needs to know about what data is being passed. Whatever you put here is data passed between the first and second node privately. If you go back to LangGraph, the only way to pass state or to pass data between nodes in LangGraph is by adding them to a common state. Every node in the graph would be aware of it, which is annoying, which is kind of annoying. I get it. In Pydantic, one of the way to pass data around is just by using constructors. So whatever data I pass in this constructor, the graph is not aware of the data being passed around. I mean, just try to think about how it's implemented under the hood, okay? I know I wasn't supposed to do this on the stream, but I think we're getting very technical and I love this. I love technical discussions. What I think is happening under the hood is Pydantic Graph calls the first node's run function. It gets an instance of base node back. It doesn't care whether it has some member variables or not. All it's going to do, it's going to be like, okay, I got a base node back. Now I'm just going to call the run method on that base node. And then the subsequent run method might return another base node. And then it will call the run method on that base node. And Pydantic Graph will keep calling the run method on every subsequent base nodes till it finally gets the end node. And once you get the end node, Pydantic is like, oh, the base node is an instance of end, so I can exit now. So shameless plug, guys. I mean, this chat is going crazy. This chat is talking about using reasoning models and agents. It's giving me ideas for my next stream. Crazy ass discussions going on. We're literally talking about how libraries are written under the hood. That's the point we're getting at. You want to be involved with such discussion, and especially if you're a builder trying to build things and are trying to build with a community and trying to get feedback from a community, join my Discord. The link is in the chat. Okay, cool. I think we get a rough idea on how data flow works. One of the patterns in data flow. Pydantic has 3 patterns of data flow. You can pass data around 3 different ways. Okay, cool. So right now we just saw that the run invocation of every node returns the next base node and it can pass whatever data it wanted to in the constructor. You cannot build your complete application like this. Why? Let's take a simple use case. Right now we just have 2 nodes. So whatever data we want to pass is just going to the next node. But what if there were 10 nodes? If it was a chain of 10 nodes or multiple nodes. And what if people wanted to consume the output of the first node in a subsequent node, which is not the next node? So what if there was a node 3 which wanted to use the output of first node, but second node doesn't care about it. Only the third node cares about it. In this way, what you would have to do you would have to pass it to second node any which ways. And then the second node would have to pass it again to the third node, even though the second node is not using it. So this is annoying. If you've done front-end work, and especially work with React, this problem is similar to prop drilling, where one piece of information needs to be used down the chain somewhere. So every intermediate node will have to pass it. So frigging annoying. And exactly GT lab, you'll have to store it elsewhere. Yeah, that's where the second pattern of passing data comes in. And that is the state object. Exactly how it works with LangGraph. So remember, there were 3 things here. We were using none, and string, right? The first generic type, I think these are generics, right? In Python, you call them generics, don't you? I mean, these are generics, so I'm going to call it generics. So the first type in the base node is the type of the state, exactly like the LangGraph state. No difference. Where what you could do is every node could use the context object. So remember, run had 2 parameters, right? The first parameter was itself, self, because it's a method, it needs to have it. And the second parameter was context. We did not look at the context in the first case, because if you're passing data just by using the node constructor pattern, you don't really care about the context. But now what you're trying to do is, you don't want to do that crazy ass prop drilling. You don't want to pass data across every node unnecessarily. So what you can do is you can define a class called the state class and then mention it in your base node and your graph run node. Yeah, you have to place it 2 different times. It's annoying. But now what you're doing is The first node, instead of giving the data directly to the second node in the constructor, it's going to write it in the state. That's the difference. Instead of giving the second node the data directly in the constructor, it's going to write it in the state. So Prashant just asked a question. So is the second mode of data flow in Pydantic graphs identical to LangGraph state management? No, it is not. Pydantic's state management or the graph state management works very different to LangGraph. Let me talk about this. This is an important one. Essentially, okay, in LangGraph, I don't mutate the state. In LangGraph, the state is immutable. Pydantic's graph state sounds similar to LangGraph, but it's not even close. In LangGraph, you don't return the entire state. You only return a partial state. Actually, you know what? Let me take a better example. Yeah, let's look at this graph. It's going to be a little complicated, but it's fine. So there are so many member variables in my state object, right? But every node is only giving me a partial response. They don't return the entire state. Why not? Because what LangGraph does under the hood is it treats state as immutable objects. So what LangGraph technically does is it takes the existing state and it merges it itself. So it doesn't modify it. It merges it, creates a new state object, and then passes that around. So again, you might say that, oh, Nurain, dude, just modify the state object. Why are you returning a new state? How does it matter? It matters. It matters a lot. But just remember this. In LangGraph, you never modify the state directly. Not allowed. That's a strict no-no. You return the state. Flores just asked the question. So does that mean Pydantic Graph doesn't support partial state? No, it does. If you look at my code, in Pydantic, state is mutable. So because it's mutable, I can just update whatever state I want. Again, it might seem like we are doing the same thing. It's not the same thing. Trust me. Just trust me for this. I'll get to this just in a minute. Okay? In Pydantic, you can update or mutate the state directly. State is mutable. In Pydantic, you modify the state. And in LangGraph, you return the state and LangGraph is responsible to merge it in. It's fine if you don't understand why is this difference important. That's fine. We're getting into it. But at least tell me if you understand the difference of that, okay, one is immutable and one is mutable. Like, do we get that? This is so much better than other YouTubers who just go, oh my God, look at this new framework, read the docs, go through the example, tune in for my next video. This makes me so happy. Thank you so much. I really appreciate it. Do subscribe. I mean, do watch my next video, man. Do watch my next video. Like, why not? This is true deep dive. I really appreciate it. Thank you so much. This is amazing. Never heard this version of explanation. I'm really glad you appreciate it. Don't get it why it's important, but you get it. Okay, you get it, but you don't know why it's so important. That's great. Not sure why it matters so much about immutable versus mutable. That's good. It's fine. We are getting to it, guys. We're getting to it. Okay, cool. Let's continue. For now, I'm going to leave you guys hanging. I'm not going to talk about why immutable versus mutable is so important because I just want to talk about one more data flow way, like one more way you can pass data around in Pydantic. And this is my favorite. This is my personal favorite. Okay, so what did we see so far? One was passing data directly through constructors. Great. The second was passing data through state, which we are essentially saying is that the node is generating some state. And it's generating some state which the other nodes would be interested in. So for example, the intent classifier. The intent classifier classifies the intent, but it's not just used by these guys. The intent is technically used over here. So this is where you need to use state, okay? Here you're technically talking about data, which is like JSON. It's literally data. What I'm trying to emphasize here, it will never be a database driver. It shouldn't be a database driver. It's always going to be some data, which means you can stringify it. You can dump it. Yeah, I think Python calls it dump, right? You can dump it into a JSON string and store it in a database somewhere. That's the kind of data which I would put in a graph. There's a big reason for it. Oh my God, I know I'm leaving you guys hanging for so many things. All right, but what if I want to pass some other kind of data, which is not technically data? What if I want to give an agent access to my database driver? Because remember, one of our agents was talking to a database. You can't pass a database driver in the state because it cannot be stringified. You cannot stringify or you cannot dump. You cannot JSON dump a database driver object, right? That's just weird. So whenever you're talking about non-data objects, you cannot use state. right? Same thing in LangGraph. You cannot use state. And because of that, Pydantic has come up with a third flow pattern as well, which is dependencies. So dependencies are dependencies, what it sounds like, right? These are dependencies for the graph. So nodes can modify the state. Nodes cannot modify the graph dependencies. The second parameter which we had here, that's dependencies. The first parameter which we had here was state. So the first one was state, which nodes can modify. The second one is dependencies, which nodes can only read. Again, none of this is explicitly mentioned in the documentation, okay? We are in opinion territory. I'm sorry, I should have mentioned this again. All of this is opinion territory. When I'm running my graph, sorry, I didn't show you this earlier, but like you can make an empty state object here. And similarly, you can pass a dependency object here. LangGraph also uses mutable state model as well. I don't think it does. I really don't think it does. I'll tell you why. Okay, let's get into that. Okay, so these are the three ways. Constructor, directly pass stuff in the constructor over here. The second is directly set the state and use the state across. So really good if that action needs to be used by a lot of nodes, then just put it in the state. But remember, state has to be JSON dumpable. Okay. And the last one is dependencies. Dependencies is essentially stuff which I said, like it's database drivers and stuff like that. Okay. This is better than the docs. Thank you so much, Prashant. I appreciate it. This is what we're here for. Thank you so much. I want to show you one classic example of LangGraph, which Pydantic cannot do today. LangGraph has the ability to do map reduce. That is, it can do parallel execution. This is what we had done last time. Essentially, what I was saying is that in this example, I'm returning tasks, right? So if you're trying to read, I'm reading task, and let's say there are 10 tasks. So if there are 10 tasks, I'm going to run 10 LLM prompts to enrich that task. And then once all 10 are done, I'm going to run the formatter. So, and these are all state objects, right? So all of this has to go in the state. But think of the problem. I'm running 10 functions concurrently. Python is single threaded, so it doesn't matter. But imagine if it was not really concurrent, it was parallel. So they're actually running on 2 cores. Now, if I was trying to update the state in each one of these functions, if I was trying to run, let's say this node is running parallelly, right? And so there are 2 instances of the first node. There are 2 nodes running parallelly, and both of them are trying to append to the state. So they are essentially trying to do something like result plus equals to whatever content. Something like that. Let's say it's doing something like this. What do you think will happen? You will get a data race. 2 OS threads, 2 threads on the operating system are trying to access the same memory location, not in a read access, in a write access. They're trying to write to the same memory location parallelly, not concurrently, parallelly, together. That's what we call a data race condition. That's when your application crashes. So now this is a problem. This is where immutability helps a lot. Because what immutability helps you do is, let's say these are 2 processes which are running, and this is my memory location. So they both are trying to write to this memory location together. These are my 2 processes, process 1, process 2, both are trying to write to mem location simultaneously. Not allowed. If you use the way LangGraph does things, and you do this instead, where you're not accessing it, you're just like, hey, LangGraph, why don't you take this object and do something with it and merge it? Now what LangGraph could do is, LangGraph could essentially say, you know what? I'm running yet another thread. So this guy gives me a state. So it gives me state 1. This gives me another state. I'm using a reducer. Explorer, you were right. I'm using a reducer. And what I say is, right, I'll take it one at a time through a mutex or whatever. And I will update this memory location instead. So it's definitely using some kind of mutexes under the hood. But as developers, we don't have to worry about this. This is called concurrency control. LangGraph is essentially saying that, hey, I'm getting the return object. I'll take one at a time and I'll use a reducer. And that reducer will essentially reduce multiple inputs into a single input. What is the reducer's job? A reducer essentially takes in an array of elements one at a time, and it maintains mutable state. Not technically mutable, but it seems like it's mutable. And what it will do is, it will take one object, it will modify the state. It will take the second object, it will modify the state. That's exactly what immutability helps you with, right? So anybody who's used LangGraph, if you go over here, you'll notice that You annotate this. Their main example has this annotate stuff. What is this? This is a reducer. What it does is it takes the array of messages you've given it and it concatenates it with the array of messages in the state. You are not doing the concatenation. This reducer is doing the concatenation. The reducer is called by LangGraph under the hood. Does that make sense? I really hope you understand mutability and immutable state. What are the implications? Immutable state, the way LangGraph does it, allows for concurrency. You cannot have concurrent applications in stateful world, like when you're updating the state directly, unless you are implementing mutexes yourself. Yeah, cool. Alrighty. Sweet. That was the first thing, immutable versus mutable. The second thing was dependency versus state, right? So another aspect of graphs is that, let's say we have a graph right here. What if my process dies at this step? What if I run my intent classifier, I run my title matcher, I get to the exec and it dies? The process exits. I want to renew it, right? I want to continue it. So by default, you might just run everything again. But AI is expensive. You don't want to run it again. Wouldn't it be great if you could take that state and just store it somewhere? So now what you could do is instead of running all of this again, you can replay it. Because you already have the state somewhere. You can just say that, okay, you know what? I already know what this guy did. I already know what this guy did. And I already have the state stored somewhere. I can just use that state and resume this from the checkpoint. So I'm technically checkpointing. I'm storing that state in like a database somewhere after every step so that if it crashes and I want to recover, I can just replay those states. So what I'll do is I'll be like, hey, intent classifier, you run again. But hold on. You already gave me the output which I have in the database. So instead of running the intent classifier again, I'm essentially going to be like, oh, you know what? Intent classifier already ran. I already have its result in the database. So I'm just going to pull it from the database and I'm going to see what it returned and assume that it's run again. This is called replay. I'm not going to get into a lot of detail into how this works. But if you want to understand this better, check out a tool called Temporal. Temporal explains these concepts really well. Temporal is one of my favorite tools. It's essentially what this is. It's a workflow tool. Not graph-based, it's just a workflow tool. But now you see what I'm doing. I'm taking the state and I'm going to store this state in a database after every step, which means it needs to be parsable. I need to be able to JSON dump it because I cannot store the state externally if it's not parsable, if I cannot convert it into JSON. And that is why the state object has to be parsable, because if the state object is parsable and you can dump it as JSON, you can persist it. You can persist it somewhere. However, if it's a database driver, you cannot persist it somewhere. And you might be saying, TechBud, what the hell are you saying? Nobody cares about these things. Actually, they do. Just look at LangGraph's persistence. LangGraph's persistence essentially has a state object, right? And then it creates something known as a checkpointer. What is this checkpointer? This checkpointer is nothing but doing a JSON dump and storing it either in memory or in a database. And if you had put database drivers in your state, you will not be able to checkpoint it, which means LangGraph has no way to use database drivers as dependencies. Because the way LangGraph works, the entire state object will be checkpointed, unless I'm wrong. Unless they have a mechanism to make sure that, you know what, in this state object, not every field will be checkpointed, but I don't think so you can do that. Every field is checkpointed. But the point is, if your state object has database drivers, you cannot checkpoint it, which means you cannot do replayability and all that cool stuff. And that's pretty much the essence of the persistence module in LangGraph, guys. That's literally what LangGraph persistent is all about. That's how interrupts works in LangGraph. That's exactly how a lot of things work in LangGraph, which is a big problem. So dependencies allows you to put in non-parsable entities which need not be persisted. Like you don't need to persist the database driver, right? You can construct it again and again every time. It doesn't matter. That's why Pydantic, in my opinion, has a separate state object and a separate dependencies object. Dependencies object cannot be parsed and they are not checkpointed. State object can be parsed and can be checkpointed. You can convert it to JSON. You can store it in a database. And state object, as long as you have the entire state object, you can replay the graph again. I know this probably was way too complex. I'm so sorry, guys. I am so sorry, guys. Flow control of LangGraph is far superior than Pydantic, to the point where Pydantic doesn't even have an opinion on how to do it yet. I'm not saying they never will do it. I'm just saying they haven't reached that point yet. But I'm sure they already have plans. Let's look at the final graph just quickly so that, we have some closure. The graph looks something like this. Intent classifier decide what comes next based on the action. And then if the action was add or get, we directly go to the task executor. But if it was supposed to be marked as done, we go to the title matcher. The title matcher will figure out what's the right title, and then it will go back to the task executor to mark the task as done. And of course, we'll have a task summary if it was get task or not. Cool. How did I implement this? I'm not sure if this is right. I'm still trying to figure the right way to use the 3 different ways of data flow. I don't know which one to use where yet. It's a little tricky. I'm not going to lie. It's a little tricky. This is what I've done so far. So I have my classifier node. That's my entry node. That's my start node. What it does is, again, I'm using Pydantic agents here. These are the same agents we spoke about in the previous stream. But it's nothing but, structured response. It's Pydantic's structured response, which I absolutely love. Amazing feature. Guys, Pydantic structured response and dependency injection. Amazing. Love it. Cool. So all this is doing is it's returning me a structured response. And that structured response I'm storing in the state, because intent is something I'm going to be using throughout my graph. Anything which I'm going to use a lot in my graph and was generated by a node goes in a state. And then I'm just doing a simple switch case, right? Again, the ugly switch case. This is why I don't like using the command thing in LangGraph or returning the next node. I don't like it because you're still doing the stupid switch cases. I mean, you have to do the switch case anyways. But the point is, my classifier node is bound with these nodes. I cannot use the classifier node in another graph because the classifier node is bound and it's gonna be like, oh, you know what? I can only forward my responses to the task manager or to the title matcher. It's hard-coded inside the node. This is so annoying. The advantages with edges was that the node was reusable. The node did not care who comes in next. So I could reuse the same node in different graphs because it doesn't matter. Like the summarizer. The same summarizer node could be used in so many different places, right? Summarize tasks, meeting notes, summarize so many different things. But because the node here has to return the next node all the time, it's not reusable anymore. I don't like it. I'm going to be honest, it's just my opinion. I love reusable stuff. Returning nodes directly really puts a dampener on reusability of the same node. Cool. So what am I doing here? I'm just putting a match. So if it was get task, I'll go to my get task manager. My get task manager, I'm explicitly, this is where I'm doing my instruction stuff. Remember, my second qualm with Pydantic was that the instructions are leaky. Kind of containing it, kind of, not exactly, but kind of. I kind of like it. What I'm saying is the instruction that I need to pass to the agent, I'm passing that as a constructor parameter. This approach helps with open source models a lot. Because remember this, open source models start to struggle when the number of tools inside that one agent becomes large, right? But what we've done here, because we are really making a fine-tuned instruction saying exactly what to do, it's easier for the agent to make a decision of what tool to call. And then I'm calling end if I get something weird. And that keeps going on, guys. That keeps going on. If it was a title matcher, if it was mark as done, it was the title matcher. Again, I'll call the agent which tries to figure out the title. The agent will be responsible for calling the database and doing all of those things. That's why Pydantic is so awesome, because I don't know what the agent is doing. I don't know if the agent is going to talk to the database or not. I don't know if it's going to be doing this. All I need to do is pass it dependencies. Yeah, the database driver or things like that. That comes through the dependency object, right? And you just pass the dependency as is. And my query again comes from the dependency. This query is the original query of the user. So the original query of the user, I've put it as a dependency as well. Why? Because I don't want any node to modify it. Again, you could technically put it in the state. It's fine. I think it would be better if you put it in the state now that I think about it, because it's easier to replay things. The query needs to be in the database as well when you checkpoint. Got it. This is wrong. The query should have been in the state. My bad, guys. You found a bug. And then, yeah, if the title was not present, just end it. Otherwise, go to the task manager. And then the task manager does the same thing. It calls the agent. And this is what I don't like. This is what I absolutely hate. Task manager's job in life should only be to call the task. That's literally all it should do. But because I need to return the next node in this node, task manager has to remember whether it was get task or not. And then if it was get task, call the goddamn task summarizer. Why is the task manager concerned with this? The task manager should only worry about working with the database. Why is that worrying about whether it needs to call the summarizer or not? That is stupid. I really don't like this. So again, you see why I prefer keeping edges and nodes different, right? I just don't like it. I don't like it. And yeah, then you have the task summarizer agent, and then it just does the end, and that's pretty much it. That is pretty much it, guys. I can show you how this runs, but I think we've already seen that ahead, so I'm not going to do that again. But any questions? Or there are texts. So in case of Pydantic Graph, we need to partition the state or lock using async IO, which beats the purpose of making it sequential versus parallel, or maybe make a local copy before changing global state. Technically speaking, Explorer, that's a good point. What I understand, Python fundamentally is single-threaded. And nobody in an agentic system would actually spawn OS threads. You would spawn async IO tasks, but you would never spawn OS threads in Python. So it's fine if you mutate the state because async IO doesn't really run two tasks simultaneously. Again, I could be wrong. I'm just assuming it works similar to how the Node.js event loop works. I think that's the case in tasks as well. You cannot run Python code simultaneously. So Python is concurrent. It's not parallel. So technically, you should be fine if you don't even use mutexes because it's single-threaded, like single OS threaded. So I think you're fine. What does PydanticAI Graph code looks like when node A calls both node B? Exactly. Jim, great question. Love you. PydanticAI doesn't support it. At least it wasn't mentioned in their docs. In their docs, essentially, you can never say that, okay, I want to return two nodes. You can always say that it's going to be one of these nodes. It's going to be one of these nodes. It's like a union. I think it's called a union. So it can be a union, but you can never return two. There's no concept of concurrent execution at all, but they will add it. I'm pretty sure they will add it. It's not a big deal. So to summarize, LangGraph is more feature rich than Pydantic in almost every way imaginable, but it's just a matter of time. LangGraph had like a year head start compared to Pydantic Graph, so it's going to be way better than Pydantic Graph as of today. So it's not a fair comparison, but the stuff Pydantic is lacking isn't that major that I would say that it cannot catch up. It can definitely catch up with almost everything. However, I do have to give kudos to LangGraph because its state management is way more advanced than Pydantic, to the point where Pydantic doesn't even have any trace of how it's going to solve it, especially when you get into the concurrent territory, right? So state management in LangGraph is really advanced. And lastly, orchestration, LangGraph is really good, especially its fan in and fan out stuff. Like it can separate out tasks, fan in and fan out, concurrency stuff, really good, really good. It also has this checkpointer, so replaying and stuff like that is really good. But I do remember seeing an issue in Pydantic Graph where checkpointer is literally like the next thing they're implementing, I guess. So it's not far away. But yeah, LangGraph is ahead of it. But even though Pydantic is way behind, I still think it's on stronger grounds. I think Pydantic has a better opinion. It has the late mover advantage where it's trying to like fix the problems. Like with LangGraph, you can't do dependencies. Pydantic fixes it. So it has the late mover advantage. And I think I'm kind of appreciating the way they've done things. There are some things I don't like they need to have support for, defining graphs by keeping edges and nodes separately. I think that's really required if you want to make composable stuff. It's really important. But really, the fact that they have 3 different ways of passing data around, I think that shows a lot of progressiveness. They're looking far ahead in time. That's a really good feature. I really love it. And I'm not sure if you guys have noticed, but Pydantic is async by default. In fact, all its docs are just async. Everything is async. It just works async. I really like it because it makes productionizing this even easier. Then another important point was, it's a different mentality. LangGraph is more functional. So if you're used to using functional languages, which I know Python is not, but if you come from the functional world, LangGraph will feel more at home. Pydantic is more object oriented, in that way. But it's a personal preference. I don't think so. It's feature limiting. It's just a personal preference, right? Like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech bud. You're on YouTube and hopefully in real life.